Bridges are built to withstand strong winds, heavy traffic, and even earthquakes. But what if I told you that a bridge once collapsed? This is the shocking story of the Tacoma Narrows Bridge, a real life example of the powerful concept of resonance. Let's break it down into simple physics. The Tacoma Narrows Bridge was built in 1940 in the US state of Washington. Soon after its construction, engineers noticed that it would sway unnaturally in strong winds, even at speeds as low as 64 kmph. But on November 7, 1940, a wind of around 67 kmph caused the bridge to oscillate violently. It twisted, bent, and finally collapsed into the river below. But why? The answer lies in the concept of resonance. Resonance occurs when an object is exposed to periodic forces that equal the natural frequency. Think of a child on a swing. If you push it at just the right moment each time, the swing goes higher and higher. That's resonance. But if you push randomly, the motion remains unsteady. Like a swing, every structure has a natural frequency of vibration, the frequency at which it vibrates when disturbed. The Tacoma Narrows Bridge was long and narrow, making it more flexible. On that fateful day, the steady wind equaled the bridge's natural frequency, creating a forced vibration. Each gust of wind added energy just like timed pushes of a swing, amplifying the motion more and more. This phenomenon is called aerolastic flutter, a type of resonance in structures. The resonance takes place because of the frequency of the external periodic force, that is, the wind in this case, equaled the natural frequency of vibration of the body, in this case the bridge, and because of that, resonance took place and the body, that is the bridge, began to oscillate with larger amplitude. This is an example of resonance. In this case, resonance resulted in the collapse of this bridge. At first, the bridge showed small oscillations, but as the resonance built up, the oscillations grew uncontrollable, twisting the bridge into an extreme shape. Eventually, the stress was too much and the bridge collapsed into the river. After the disaster, the engineers learned valuable lessons. Today, bridges are designed with aerodynamic modifications and dampers to reduce resonance. They also conduct wind tunnel testing to prevent similar disasters. The Tacoma Narrows Bridge collapse was a spectacular failure, but it helped improve engineering worldwide. Resonance is not just a physics concept, it affects buildings, vehicles, and even musical instruments. So, next time you feel vibrations in a structure, remember resonance can be both fascinating and dangerous. If you found this explanation helpful, don't forget to like, subscribe, and stay tuned for more amazing science stories.